Welcome to Fire Engineering Training Minutes. My name is Paul LaRochelle, and today we're going to talk about portable bandsaws, both electric and battery operated. If your department does not currently have a bandsaw, it is the preferred tool for cutting any kind of metal. It does have its limitations, however, and we're going to talk a little bit about that as we go along. One of the first things that you would consider is the size of the material that you will be cutting. And that will be determined by this opening here in the bandsaw. So imagine about a 6x6 size would be sufficiently cut with this bandsaw. If you opt for a smaller bandsaw, everything is going to involve a trade-off. Smaller will be lighter, it'll get into some tighter spaces, but you will not be able to cut as big a material. So you have to decide for your department's needs what you want. Ideally, if you have the ability to, having an electric bandsaw and a portable battery-operated bandsaw will allow you to be able to work in any environment, even remote locations. Each bandsaw, again, has its own features, its own unique features. Some of the bandsaws have a variable speed which is built in at the trigger. Others have a variable speed where you dial up the number that you want, and that allows you to have a constant speed setting. All the bandsaws have what we would call a shoe or a base. This is where your material needs to lie when you are about to make a cut. The tendency is to have your material in the middle of the blade when you start, and what will happen is it'll immediately slam against the base, which will likely cause pain for your victim, but also broken teeth on your blade, which will result in a thumping sound each time those broken teeth come around. So we want to avoid that at all costs. Ideally, if the material that you're cutting is against the base and the blade is now in motion, that is the best operation. So you're less likely to damage the teeth, and it will definitely help your victim. These bases also have the ability to move. Some of the bandsaws, the base is stored in the closed position or the shortest position. So that would have to be adjusted at an incident, otherwise it will not fit in the case. In this particular bandsaw, we'll show you that the shoe is actually stored in its closed position. So in order to deploy that, you have to find the wrench, the Allen wrench that goes along with it. So knowing your saw, that wrench is located on here somewhere. You'd have to find that and be able to make that adjustment. And it's just simply loosening these bolts, which it's pretty common to take off your glove to have a little more dexterity. Loosening the two Allen bolts, deploying the shoe where you want it, and then retightening the bolts. So the lesson in this is, even though this looks like a simple device that you probably have used before, each of the devices have their own little idiosyncrasies that you need to be able to find ahead of time. And that is done through training. Now that we've got the base where we want it, we hopefully have a brand new blade for our use for our victim, but in the event that we need to do a blade change, the first thing always is lockout, tag out, take away the power supply, whether that's removing the battery or unplugging the saw. The next step is going to be taking this control arm and moving it so that it puts some slack in the system. Sometimes the blade will pop out on its own, other times you have to pull it out. Now, each of the blades has a different, what's called TPI, which is teeth per inch. And the bigger the number, the smaller the teeth, because it's telling you you have more teeth per inch. So on each blade, you'll notice that there is a number up here. It's a dimension of the length of the blade, but also a TPI number. So 24 TPI indicates 24 teeth per inch. That means they're going to be very small teeth. One of the things that can trip you up is if I simply take this blade and flip it like this and put it onto my saw, the teeth are facing the wrong direction. So this will immediately flatten out the teeth and it will render it useless. So if somebody at a training is just randomly manipulating the blade like this, they might set you up for failure. It could potentially come out of the package that way. So it's important that you know the teeth always face your base or your shoe. All right, that's your indicator. So in order to replace the blade, I'm going to just start at the bottom. I have to get the blade in where the rollers are, and then I'm going to work my way around, nice and easy. Sometimes having somebody to assist you is useful. And as I work my way around, I want to be careful not to push so hard on these wheels that I push the rubber traction devices off of the wheels. And once I'm in position, I go back to my handle and I lock out and tension the blade. And now I'm ready to apply power again. Once the blade is on, it's generally going to self-align at its own position, okay? The saw itself shows you an indication of which way the wheels should turn, which way the blade should drive, but remember, it always needs to go towards the base. But right now, we're going to actually make a cut. I'm going to have my helper here, my assistant Jimmy Adams, come in, and we're going to cut this piece of pipe. And again, we're going to show you how quickly we can accomplish this, how smoothly we can accomplish this, how very little response we're going to have for our victim. So, okay, Jimmy, if you would make a cut. And you can see 15 seconds, and that cut has been beautifully made, nice, very little burrs on it, and there's virtually no heat transfer. So very little sparks, virtually no heat transfer. There is, however, metal sawdust that you don't see that could impact your victim. So we want to always do our EMS diligence, protecting the wound and protecting it from contamination from metal fragments that will come off of this cut. My name is Paul LaRochelle. This is Jimmy Adams. This has been another episode of Fire Engineering Training Minutes.